Ignition sequence starts.
Good morning and welcome to Mission Control Houston. You're looking at the International Space Station Flight Control Room, where Flight Director Ed Van Cise and the Orbit 2 team of flight controllers are on console keeping tabs on station systems and working with the Expedition 59 crew members as they wrap up another week's work in space. Commander Oleg Kononenko and his crewmates have spent a lot of time this week working on science experiments, but they also helped 2 cargo ships finish their missions and leave the station to their respective fates.
Welcome to Space to Ground. I'm Leah Cheshire. Crew members waved farewell to 2 spacecraft this week upon their departure from the International Space Station. The SpaceX Dragon completed its 17th commercial resupply mission after release from the station's Harmony module on June 3rd. The spacecraft arrived to the orbiting laboratory on May 6th, bringing about 5,500 pounds of science, hardware, and crew supplies. Dragon splashed down in the Pacific Ocean, returning about 4,200 pounds of experiments and other cargo. The Russian Progress 71 spacecraft also left the station after a 7-month stay. When Progress arrived in November 2018, it brought with it almost 3 tons of supplies. Contrary to the SpaceX Dragon, Progress is designed to burn up upon re-entry into the Earth's atmosphere, destroying with it trash and other crew disposables. As we venture farther away from Earth, providing crews with food and supplies will take longer, so we're learning how to grow plants in space. Currently, we're studying what might be on the menu. The 4th veggie experiment was installed this week, and crew members will monitor the crop, this time Mizuna mustard, for 28 days. Astronauts will observe growth patterns related to fertilizers and light quality before conducting a taste test upon harvest. Research like this is just one of the ways the space station is helping us prepare for future long-duration missions, like a return to the moon by 2024. This week's question is from Jonathan, who wants to know what kind of living quarters astronauts have. The space station might be the size of a 6-bedroom house, but the bedrooms themselves aren't so spacious. Each astronaut and cosmonaut on the space station has his or her own personal space called crew quarters. These areas are about the size of a small closet, and many astronauts personalize the walls with photos from home. This is where astronauts sleep or relax, with the ability to watch movies or talk to family and friends. Keep sending in your questions using the hashtag AskNASA. We'll see you next week.
On the subject of small spaces in space, the Flight Analogs project of NASA's Human Research Program contributes to the preparation for future missions out into the solar system by simulating the confinement and isolation of a ship on a lengthy spaceflight in order to learn what it'll take to support human crews on those missions. Another human exploration research analog mission is underway right now here at the Johnson Space Center. Take a look inside the habitat and see what it supports for volunteers during a 45-day-long test.
We can simulate what it is like to be in a spacecraft. So the isolation, the confinement, the controlled environment. The research investigations are aimed at answering some of the questions that we need to answer before we send people on those extremely long duration missions, such as to an asteroid or to Mars. It's probably about the size of, I'll say maybe a 1-bedroom apartment that's not terribly luxurious. But on the other hand, it emulates what you might see in a spacecraft. A lot of the things that you have on the first floor are things like workstations. Some of the computer and some of the simulation devices are on the first floor. We have a lot of capabilities for performing different kinds of experiments. The second floor, it's kind of like your living room. There's a table that the crew members can sit at and eat their meals. All of our food right now is coming from the Johnson Space Center Food Lab, which means it's the same food that goes to the International Space Station. There's also a capability for them to play videos or to watch movies. We have a couple of exercise devices, a bicycle in particular, and then we also have some free weights. We find that a lot of our crew members will also do some calisthenics, some stretching, maybe some yoga. So there's a tiny little place for them to be able to do that. The final level, if you will, is really not a full story. It's really the sleep quarters. It's bigger than a pup tent. Each crew member has his or her own sleep quarters. It's actually very cozy, very comfortable. The hygiene module has a flushing toilet. We have a stand-up shower with hot and cold running water, and we also have a sink with hot and cold running water. The final element of the module is a very small module that is an airlock. And we do isolate or subdivide the crew such that 2 crew members will go into the airlock, and that is where they'll do their virtual reality EVAs from.
I'm excited for the challenge. I love a good challenge. I'm a professor at Grand Valley State University. I teach biology. I feel like I'm actually playing, it's a small role, but it's a real, tangible, important role in getting people to Mars. The first thing I saw about this was on a Facebook posting, and a couple of former Hera crew people had posted that they had just come out. I didn't think I would be selected, and I just kind of did it on a lark, and it worked out awesome. They are measuring us in more ways than I could have imagined. We've given a lot of biological samples of various types. They're measuring our heart rate, our brain waves. They're doing a tremendously large number of psychological tests on us.
This mission, the crew members are going to an asteroid. So while they are on their way to the asteroid, they are going to practice their flying skills. Once they get to the destination, they're also going to be conducting some virtual reality EVAs. So on the way there, they're also practicing those skills. We have the housekeeping tasks for them. We have maintenance types of tasks. A primary purpose for the mission controllers is really to ensure the safety and well-being of the crew members who are inside the Hera, to make sure that everything is going well. But it's really also to, as much as possible, to keep all of the scientific investigations happening as they're scheduled on time, to answer any kind of questions. We provide some input, a newspaper, if you will, electronically to the crew members in their, I'll call it their morning mail. Not allowing the internet access really does allow us to keep the crew members really engaged in the mission and not to be, concerned about things that are going on in the outside world. The one little luxury, if you will, that they have is approximately once a week, we schedule them for a private family conference. So a telephone call that is patched in on a private phone line. We do plan to keep the Hera operating for at least another 4 or 5 years. The 45-day missions, we're always going to be looking for qualified crew members to be able to come and join us and participate in the research studies.
The Bigelow Expandable Activity Module has provided some extra space on the International Space Station for the past 3 years. After more than a year and a half on orbit, providing performance data on expandable habitat technologies, NASA and Bigelow Aerospace agreed to make Beam a more operational element to the station, used in crew activities and for onboard storage. It allows more time to gather data on the module's structural integrity, thermal stability, and its resistance to space debris, radiation, and microbial growth. Research on technology in space is part of the International Space Station's science mission, an experiment called optical fiber production in microgravity, provided by the private company Made in Space, operated on the space station for a few weeks, and then returned to Earth on the same Dragon spaceship that brought it to orbit. Its goal was to demonstrate both the scientific and the commercial merits of manufacturing exotic optical fibers in space.
We're excited at Made in Space to work with NASA and CASIS to use the ISS National Lab. Made in Space fiber optics is a payload to manufacture Z-band glass fiber in microgravity. It will produce hundreds of meters of very, very high-end optical fiber. Manufacturing fiber in microgravity has been theorized to increase the performance by creating a better product. And by better product, I mean a clearer, more pure glass. And that is due to the microcrystal formation. It makes the glass a little cloudier when the crystals form here on Earth. And in space, it'll be more pure and clear. And in microgravity, they form in a different way, in a more pure way with fewer defects. What could happen is a 100-time increase in performance. This is a really cool project because it can benefit everyone here on Earth. You know, fiber optics are used for various applications, medical devices, lasers, but also internet. And this can really help, you know, improve bandwidth and performance and lower the cost of internet and data centers. So really, it's a product that can affect everyone.
The International Space Station has science experiments underway in many scientific disciplines, not just technology development, but also human life sciences, plant biology, many more. One thing that all of these experiments have in common is that they are taking advantage of a condition on the station that cannot be replicated anywhere on Earth: microgravity.
An out-of-this-world research lab. Presented by Science at NASA. Every now and then when the sun sets, a bright light appears on the western horizon. Gliding silently overhead, it is the biggest spacecraft ever built by humankind, the International Space Station, or ISS, carrying a precious cargo of astronauts around Earth. But the ISS is more than just a bright light in the night sky. It is also an out-of-this-world research laboratory. The interior of the ISS is furnished with laboratory equipment and chambers for experimental research. It's not as large as some Earth labs, but it has one thing that Earth labs do not: microgravity. Gravity influences everything that happens on Earth. It's hard to envision what life would be like without this force, yet removing the pull of gravity can be uniquely instructive. Reduced gravity provided by the ISS is a major attraction for researchers, says Joseph Nugget of NASA's Johnson Space Center in Houston, Texas. The weightless environment allows scientists to gain insight into basic phenomena in many fields. For example, says Nugget, we all have seen that roots of plants grow down into the earth. Is this because of gravity? Experiments with plants on the ISS can tell us. Understanding how roots grow is directly applicable to space exploration. What does NASA need to consider when designing a plant chamber for food or life support in space? Farmers on Earth are interested too. A deep understanding of roots can help scientists design hydroponic chambers for agriculture in areas with poor soil conditions. Since the first modules of the ISS were launched in 1998, up until 2017, more than 2,400 investigations have been undertaken by over 3,400 researchers in over 100 countries. Astronauts have spent more than 36,000 hours helping run the experiments for scientists back on Earth. To date, more than 1,600 scientific journal and magazine articles have been published reporting the results. It's a scientific bonanza. There are 5 major research areas on the ISS: biological sciences, such as the root experiments; physical sciences; space science and fundamental physics; human research; and earth science. Nugget has favorite examples of each. Scientists grow crystals on the station to discover new crystalline forms. Protein crystals grown in small chambers on the station reveal information that helps find new, novel ways to combat disease. The space station is also equipped with furnaces that can melt solid metals and alloys. This can reveal the metal's crystalline structure in a new way and give greater insight into the properties of the material. While protein crystals are a biological science and metal solidification is a physical science, both are examples of how crystalline structure develops in microgravity differently than on Earth. Switching over to fundamental physics, he says, there are several investigations on the ISS that examine fundamental laws of physics and continue the search for theoretical particles. The alpha magnetic spectrometer, for instance, provides valuable data on the existence of dark matter. Human research is also very interesting and dynamic, helping NASA get astronauts ready for deep space exploration with many spin-off benefits for people on Earth. Nugget notes, research like the lighting effect study helps improve our flight team's productivity on the ISS and on the ground here in Mission Control, as well as the many American workers who work on night shift or alternating shifts. One-year missions to the ISS return much information about how the human body adapts to space travel, from the genetic level to how the astronaut deals with the long-term isolation within the spacecraft. Not all research conducted on ISS requires reduced gravity, he notes. For example, the ISS is a great place to observe the Earth. The station passes over the vast majority of the Earth's populated areas. Sensors and cameras on the ISS can contribute to disaster assistance, tracking hurricanes, measuring wind and rainfall, as well as documenting events such as volcanic activity. The ISS, much more than just a bright light in the night, indeed. For more from the International Space Station, visit www.nasa.gov/station. For more news about science on and around the Earth, stay tuned to science.nasa.gov.
In addition to being the hands-on laboratory assistants for science in space, the International Space Station crew members use some of their time to share the experience and to help students learn about scientific concepts. Last year, astronaut Scott Tingle released this demonstration video in which he talked about the importance of nutrition for men and women who are of this planet, if not on it at the moment.
Hello, and welcome to the International Space Station. My name is Scott Tingle. Here on the space station, we live in a microgravity environment, which makes eating here a very unique experience. To stay healthy, we have to maintain a nutritious diet, just like we would back on Earth. Let's go take a look at some of our food and drinks and check out our meal preparation area. During long-duration spaceflight, we have to make sure that we receive enough energy, proteins, and vitamins. Our food lab back on Earth makes sure we get plenty of each as they carefully prepare, test, and package everything. We combine all of this excellent nutrition with exercise to ensure our bodies stay healthy and strong while we're here. We eat 3 square meals a day, just like we do on Earth, and maybe throw in a snack or 2. One of my most favorite foods to eat are natural raisins. Here on Space Station, we have to keep our calories up if we want to get all our work done. And the carbohydrates in these raisins really help. And they're kind of fun to eat, too. And how do we stay hydrated in microgravity? With these special pouches. They're filled with water, and we use a straw that has a one-way valve that prevents water from floating out of the pouch while we're not drinking from it. Here's a liquid drink. This is a tropical punch for today. I love drinking fluids on station. Here on station, we have a pretty cool food preparation area. We have a place to get fresh water for us to drink or to put in our rehydratable foods. And we also have an oven to put food in. We pick out some of our favorite foods, chicken fajita for me. Put it in the oven. Close the door and turn it on. In about 15 minutes, I'm gonna have a warm meal. Thanks for exploring a little nutrition with me. I'm gonna send you back to Earth so you can create your very own astronaut menus. See you again soon.
NASA's Human Research Program is using the International Space Station to learn more about how living in space impacts the human body, so we can figure out how to counteract the negative effects and protect future astronauts when they explore out beyond Earth orbit. That includes dealing with the radiation that astronauts are exposed to when they're outside the protection of Earth's atmosphere. In this installment of the series on space radiation, HRP scientists discuss the biological risks that future astronauts will face on missions out into the solar system.
So of all the things that the Human Research Program is investigating, the biological consequences of radiation exposure is one of the major ones. Some of the reasons for that is that the health consequences following radiation exposure are very complex processes. It's difficult to quantify exactly how the radiation is interacting with tissue, and then it's even more complicated to try to quantify and determine what the long-term outcomes are going to be in terms of things like carcinogenesis, central nervous system effects, and detriment to the central nervous system.
The primary means by which radiation affects cells is by damaging their DNA. You can get breaks in the strands in the double helix, you can knock bases out, and the cell will make an attempt to repair that damage. Sometimes it's effective, sometimes it's not, and sometimes it'll actually get repaired, but in an error-prone fashion, so it's what we call misrepaired. So anything that sets into the genome in that way is a mutation, and the accumulation of mutations can potentially lead to cancer and take a non-cancerous cell, a normal cell, and make it transformed into a cancerous one, so that's a big concern.
So on Earth, there's a couple characteristic things that are different from space. One of them is that the type of radiation we experience on Earth is generally what we refer to as low LET radiation, things like gamma rays and X-rays. We also have the protective shielding of the Earth's magnetic field and the atmosphere, which shields a great deal of the radiation. And then finally, we have things like radiation protection concepts such as time, shielding, and distance. So we can reduce the time of exposure on Earth, we can reduce the distance from the radiation sources, and we can reduce the exposure through shielding. In space, a lot of those things are very different. So we have a very complex radiation field that includes things like protons and all the particles on the periodic table of elements. They're coming in at energies that are approaching the speed of light, and they're difficult to shield against, and they're always there. So the concept of time really doesn't make sense because you can't reduce the exposure in space except perhaps getting to Mars faster. You can't really reduce the distance at all because the radiation is everywhere. And shielding concepts for galactic cosmic rays are very difficult because of the energies involved.
Flight engineer Anne McClain is in the 187th day in space on the first space flight of her career, with only a couple more weeks to go before she comes home. McClain's a colonel in the U.S. Army with a degree in astronautical engineering from West Point and a couple of master's degrees on top of that. But just in case you already knew all of that, here are a few things about her that may surprise you.
Okay, one thing that most people don't know about me is that I've wanted to be an astronaut since I was 3 years old. That's when I first told my mom that I wanted to be an astronaut. When I went off to preschool, I told her I was going to school to learn to be an astronaut. And when I was in kindergarten, I wrote my first very poorly written book on going to space on the Soyuz vehicle. When I was in 6th grade, I had a birthday party and I asked every single one of my friends for a calculator for my birthday. And I didn't tell my parents because I was too embarrassed, but I got a lot of calculators and I was super nerdy about it. But one of the things that I learned was, you just got to be yourself. I wanted a bunch of calculators. I got a bunch of calculators, and that was okay. I was a huge nerd then, and I'm still a total nerd now. But hey, nerds get to go to space. Another thing most people don't know about me is that I played rugby. Well, maybe if you're close to me, you probably know that because I'm a little bit crazy about rugby. And the last time that I played was about a week before I got selected here at NASA. I played in the English Premiership in England, and then I went back and I played on the U.S. national team. One of the things that I learned about myself playing rugby that I apply every single day is when you think that you have given everything and you have nothing left to give physically and mentally, you have a reserve that you can dip into and you can just keep going. I was a helicopter pilot in the Army. I flew helicopters for about 10 years before I became a test pilot. And one of the things that I learned flying helicopters is that when something looks really risky from the outside, that people that are doing it on the inside, they're not professional risk takers, but they're probably professional risk mitigators. One summer, I watched the movie Top Gun so many times, probably 3 times a day for a matter of months, that my brother finally took the tape out of the VHS and broke it over his leg so I could never watch it again. I was absolutely devastated, and so maybe it's partly his fault that I have to go live that dream as a military pilot. But you never know where you're gonna get inspiration from, and if you're inspired, well, then just keep doing it. Even if your brother says not to.
If you'd like another look at the stories we featured today, check us out on YouTube and Facebook. There are the addresses. And while you're there, look around, because there are lots of other cool things you can find about NASA and America's human spaceflight programs. You should also check out Houston We Have a Podcast. That's folks here at NASA talking about their work in all aspects of space exploration. The new episodes post on Fridays. Today, Gary Jordan talks with Mark Baldwin of Lockheed Martin about the work that's gone into ensuring that the men and women who will ride the new Orion spacecraft out into the solar system will be safe from vibrations and accelerations that will occur when it flies. Go to nasa.gov/podcasts. You'll find today's episode and all of our episodes. In fact, you will find the full library of all different NASA podcasts. You can also find all of them on Apple Podcasts, Google Podcasts, and SoundCloud. This is Mission Control, Houston.